Okay, so this is a free response question from several years ago, uh, and I thought I'd work through it to give you an idea of how to look at a problem and then how to attack the problem. So first we get, for the relationship, x squared plus xy plus y squared equals 27. Find the derivative implicitly. Now this question tells you right away what technique you need to use. But even if they didn't say that implicitly, we would know that we have to use implicit differentiation because our x and y terms are combined. We have a y squared and we have an xy term. So the only way to find the derivative, or dy dx, is through implicit differentiation. So let's get started. The derivative of x squared with respect to x is 2x. And then for the derivative of x times y, we need to use the product rule. So x times y prime plus y times the derivative of x, which is just 1, plus the derivative of y squared, which, using the chain rule, would be 2y y prime. And that's all going to be equal to 0 because the derivative of a constant is always 0. To solve for y prime, we group our terms. So I'll leave the y prime terms over here on the left, xy prime plus 2y y prime. And I will move the non-y prime terms over to the left by subtraction. So minus 2x minus y. The next step, factor out the y prime on the left. So y prime times x plus 2y equals negative 2x minus y. And then we divide. So y prime is equal to negative 2x minus y over x plus 2y. And then to be a little more precise, y prime we will rewrite as dy dx is equal to negative 2x minus y over x plus 2y. And there's our answer. Now let's move over to the next question here. We're going to copy this. And then we're going to paste it over here. And we will work with this to answer question number 2. Determine whether the lines tangent to the curve at the x-intercepts of the curve are parallel. Show the analysis that leads to your conclusion. Okay, so for tangent lines to be parallel, they have to have the same slope. And a tangent line at the x-intercept means that if this were my curve, these would be my x-intercepts. And what's true of the x-intercept is that y equals 0. So I'm going to substitute y equals 0 into my dy dx. So dy dx is negative 2x minus 0 over x plus 2 times 0, which simplifies to negative 2x over x, which again simplifies to negative 2. Okay, so if my y value is 0 and I'm at an x-intercept, my slope will always be negative 2. So in this case, since the slope is equal to negative 2 when y equals 0, the tangent lines will be parallel. Be parallel. Okay. Now let's look at question 3, or part C in a free response. Here we go. We want to find the points on the curve where the lines tangent to the curve are vertical. So a vertical tangent line means that my slope is undefined. If my slope is undefined, that would mean in a fraction that I am dividing by 0. So that would tell me that x plus 2y is equal to 0. All right. So that's one piece of information. The other piece of information that I have for this question is the original equation. So I actually have a system of equations. X plus 2y equals 0, and x squared plus xy plus y squared equals 27. Which means that now I can solve this system of equations using some technique. Most likely substitution. So I'll take my first equation and solve for x. X equals negative 2y. And then I will use that information and substitute into my second equation. So I'll have negative 2y squared plus negative 2y times y plus y squared equals 27. So that will give me 4y squared, or minus 2y squared plus y squared equals 27, which then turns out to be 3y squared equals 27. So y squared equals 9, and y equals plus or minus 3. So my 2 points will be y equals 3 and y equals negative 3. And to figure out what x is going to be when y equals 3, I will use this equation. If y equals 3, then x equals negative 6. And if y equals negative 3, then x equals positive 6. And there I have my 2 answers. So we looked for clues as to what type of question we were looking at. We saw that it was an implicit differentiation, and they gave us the original equation, so we had to find the derivative. From there, we thought about the tangent lines. They asked us about x-intercepts, so we figured out what was true there. And finally, we found when our tangent line was vertical, which meant that our slope was undefined. Hopefully, this made sense.